Lesson 3-4, Graphing Polynomials, is a wrap-up lesson of all that you have learned in 3.1 and 3.2 and as far as all the features go. So let's see how all of that applies so that you are able to read a graph and also sketch a graph. So let's start off here with a graph being given to you. So in this particular problem, notice the graph is given to you and you are required to find the function equation in any form that would match this graph. Now when they talk about any form, you have two forms. You have the standard form and you have the factored form. And both are acceptable, but what I'm going to suggest is that you just stick to the factored form once you arrive to it. Don't worry about multiplying it all out. Factored form would be sufficient. So when you're given a graph, the first step that I want you to do is I want you to find all your x-intercepts. So find all x-intercepts, if any, okay? X-intercepts, also known as zeros or solutions, whichever is the terminology you've been more comfortable using, okay? So we look at this graph and we notice that we have an x-intercept right here and we have an x-intercept right here. So I'm going to identify those as x equals -3 and x equals +2. If some of you are more comfortable writing them in coordinate form, -3, 0 or 2, 0, that is absolutely okay as well. Okay, so that's the coordinate form. Now, once you have established what those x-intercepts are, I want you to state the multiplicity of that 0, okay? So remember, you guys are going to have multiplicities of 1, 2, or 3. Now, to give you a reminder, I'm going to come over here in the upper right-hand corner. Let me use a different color here. If you have an x-axis and you have these x-intercepts, if your particular line of your graph, the curve of your graph crosses through it, okay, just crosses straight through it, it looks linear in that area, whether it goes through that way or it goes through that way, okay, that is known to have a multiplicity of 1, okay? So if it just crosses through in any direction, that will have a multiplicity of 1. If your graph approaches the x-intercept and bounces off the x-intercept, okay, some sort of parabolic shape, okay, that is going to have a multiplicity of 2. Again, this is all in 3.1. And last but not least, you have the one that looks like a cubic function behavior. If it enters the x-intercept in either direction, let me put a different color in the other direction, whether it comes in that direction or in this direction, some similar shape or form, that will have a multiplicity of 3. Now I'm going to tell you right now, Delta Math primarily just keeps the multiplicities limited to 1 and 2, because anytime you get higher than that, just multiplying gets kind of tedious, okay? So I need you to state the multiplicity. So you can do so by merely coming to your graph and writing m equals next to those x-intercepts. And these particular x-intercepts, notice the graph just goes right through the x-intercept. It doesn't bounce off, so they have a multiplicity of 1. Once you have done that, I want you also to take the time to find the y-intercept, okay, the y-intercept. And I want to remind you again that y-intercept means that your x value is always going to remain 0, okay, just like you guys know with x-intercepts that the y value is always going to be 0. And if you don't, please, this is so important that you guys remember these characteristics. The y-intercept, the x is 0. So we look right here, and when x is 0, the y-intercept is going to be a 12. So there is my y-intercept. So y-intercept is a 0, 12, or y-intercept equals 12. Okay, so now we are going to write out the temporary equation, okay? So we're going to write out the equation using the information that we have gathered. So let's say we call this graph f of x, all right? We're going to say f of x, and by the way, that's completely your decision. F of x, g of x, h of x, whatever you want. F of x equals, I want you to first start off with your unknown leading coefficient. We don't know what this is. We are going to find it. But this is your leading coefficient value, and it's unknown, so we're using the variable a for leading coefficient. And then I want you to write out the factors of your x-intercepts. So the x equals -3 has a factor of x plus 3. The x-intercept of x equals 2 has a factor of x minus 2. So here's our shell of an equation, okay? We are not done because we need to find the leading coefficient. So in order to find, let me write this, in order to find your LC, your leading coefficient, use the given y-intercept. Why? Because the y-intercept has a 0, 12 coordinate, which helps us substitute the x's and the y values, or f of x values, of our equation. So let's substitute. Let's go back to our equation. F of x will be replaced with a 12 equals, a is what we're looking for, and then we have 0 plus 3 and 0 minus 2. So we will simplify from now on. From 0 plus 3 is a 3, and 0 minus 2 is a -2. And when I multiply these two, I end up with 12 equals a -6 times an a, which, to isolate the a, I'm going to divide by -6. So a is going to equal a -2. So once I have this a value, I'm practically done with this problem, because I'll go back to the shell of my equation, replace the a value with the leading coefficient I found, and finish writing out the factors, and I'm done. I will stop here in factored format. I'm not going to multiply it out. This is where I'm telling y'all to stop and then just enter that into Delta Math. Okay? And you're done. This is your answer. This is the equation of your graph of that up there. Okay? So what I want you to do now is pause this video, and I would like you to work out the second equation. I want you to work out the second equation and then come back to check your answers. So pause the video now. Okay, welcome back. So here is the work for this problem. I called the function g of x. The key thing I want you to recognize, and hopefully you caught, that the multiplicity of 1 and 2 needed to be put on those factors. Make sure you always do exponents first. So -5 squared ends up being 25. Then 25 times 2 is 50. And that's how we got the 3 after divided 150 on both sides by 50. All right, so I'm going to let you take care of this one on your own. I will provide that answer on the answer key. Okay, let's go to our last problem. So moving on to the next side of the page. At the top, I gave you a little to-go reference key on end behavior. I wanted to remind you how that when you are looking at even functions, okay, the pair of ends are always moving in the same direction, okay? So they either work as a team, both pointing up or both pointing down. Whereas, notice the difference with odd functions. With odd functions, not so much. Odd functions are split. So whatever the other one's doing, the other arrow wants to do the opposite, okay? So O for opposite, that hasn't changed. So here is how I want you guys to be able to differentiate, okay? The leading coefficient is either going to be a positive value or is going to be a negative value, all right? If it's a positive value, I want you to notice that the arrows are going to point up when it comes to even functions, okay? Positive value means the arrows are pointing up for both on the even function, but for the odd function, what you're going to notice is you focus on the right-handed arrow. This arrow is pointing upwards, just like the positive coefficient says to do. Therefore, the left-handed arrow has to do the opposite, okay? Whereas, if your leading coefficient is negative, all right, look how this works out. If it's negative, the arrows on the even function, the pair of arrows are going to point downwards, okay? Because it's negative. When you look at the odd function, the right-handed arrow is pointing downwards. Therefore, the left-handed arrow has to do the opposite, okay? Has to do the opposite. This is the left arrow. So positive leading coefficient, point up. Negative leading coefficient, point down. If it's an even function, both are pointing up or both are pointing down. If it's an odd function, focus only on the right-handed arrow. That's why I put the R. Focus on the R, putting a big star. That's the one you are caring about, because whatever that one does, the other one has to do the opposite. So if the leading coefficient is positive, the right hand goes up, the left hand has to go down. If the leading coefficient is negative, the right hand arrow goes down and the left hand goes up. Okay? So let's move on to the degree. Now, degree of a polynomial, that was covered in section 3.1, okay? But just in case you don't remember, if it's written in standard form, if your polynomial is written in standard form, you are going to find the degree by seeking out the highest exponent. Okay, to find the degree of a polynomial in standard form, you find the highest exponent or the highest power. Okay, both of those are synonyms. So highest exponent, I'm going to put power in parentheses. Now, if it is in factored form, which is what you're going to see mostly in this section, what you need to do is you can remember it one of these two ways. You either add your multiplicities, let me write that again. Hold on. Okay, add your multiplicities, right? Which multiplicities, which in essence means what you're doing is you're adding the exponents of your factors, right? Because the multiplicities are the exponents of the factors. So however is easier for you to remember, that's how you need to remember. So please recognize, though, that I am telling you that you have two different forms. It's either standard form or factored form. All right? Okay. So here's what we're going to do. You are given a function, 2x plus 4, x minus 1, x minus 3, and x minus 5, and you are asked to graph it. So first, what you're going to do is find the degree. The degree, as you just were talked about previously, it's in factored form, so we need to add the multiplicities. The multiplicity of this factor is an invisible 1 for this one as well, and these other two. So if I add the multiplicities, the degree of this polynomial is going to be a 4, which merely means if I distributed all these factors, the highest exponent would belong to a term that has x to the fourth power. Okay, which makes sense because 2x times x times another x times another x is going to be 2x to the fourth power. Okay, so that's just to give you an idea of what's going on. Even or odd? Well, 4 is an even number, so we know it's an even function. So what does that mean? Well, upstairs, that means our answer is either going to be where the two ends are going up or where the two ends are going down. Okay, so it's going to be one of those two right there. So focus on the fact that we don't have to even worry about the right hand side of that 2 by 2 square. Leading coefficient. The leading coefficient is going to be found right here in front of the first factor. The leading coefficient there is an invisible 1. So I'm going to put LC so you know where you found this leading coefficient in the future in your notes. So since my leading coefficient is an invisible 1, okay, it is a positive value, so I'm going to put a plus. So because it's a plus, out of my 4 squares, I knew it was going to be an even function, right? I knew it was going to be one of these two. And I know that it has to be a leading coefficient where it's positive. And the leading coefficient here is positive right here. So this here has to be my answer, okay? So my end behavior sketch says that my arrows for this graph are going to be pointing both up, okay? Both of them will be pointing up. So now let's take this information and draw it, okay? I'm trying to get this. That's my OCD kicking in. There we go. It's a little bit better. Okay, so let's go draw it. You're going backwards to what we were doing in the front, okay? Instead of us looking at the graph and writing out the x-intercepts, I'm going to graph the x-intercepts. So let's first start by graphing. Oh my goodness, I need to take it off of this thing. Hold on one second. Let me turn this off. And where's my ink to shape? Okay, so let's graph the x-intercept or seps. So we take the factors, 2x plus 4, set it equal to 0, and we solve. So we subtract 4 on both sides and end up with 2x equals -4. Divide by 2 on both sides and we get x equals -2. So I'm going to come over here to the left and put a dot. And I'm going to do that for every single one of my factors. So x minus 1 equals 0. Add 1 on both sides. There's positive 1. X minus 3 equals 0. Add 3 on both sides. 3. And then x minus 5 equals 0. Add 5 to both sides. Here's 5. So we have a lot of x-intercepts. Now, I want you to also take note that each one of these has a multiplicity. And whether you write out the multiplicity or not, that's up to you. I'm going to write it really small to make it a point. You won't be able to do this on the Delta Math when you're doing it on Delta Math. But when I write a multiplicity, when I'm drawing it out, I know that with multiplicities of 1, that my graph has to go right through those x-intercepts. I'm not going to bounce off of them or anything like that, okay? Now I need to go find the y-intercept. Find the y-intercept, okay? Because if you look at the instructions, we needed to have the x-intercepts and the y-intercepts and the correct signs as far as the leading coefficient and whatnot. Remember, y-intercept means that x is 0. You have got to remember this, or you will forget how to find y-intercept when it comes to these problems, okay? So y-intercept means you need to let x be 0. So here is your function being given to you, and we're going to replace every x with a 0. So 2 times 0 plus 4, x minus 1 becomes 0 minus 1, 0 minus 3, and 0 minus 5. So I'm going to figure out, remember f of 0 is just a y, remember that, right? So what is my y-intercept going to be? Well, 2 times 0 is 0, 0 plus 4 is a 4, 0 minus 1 is negative 1, 0 minus 3 is negative 3, and 0 minus 5 is negative 5. And when you multiply this all out, 4 times negative 1 is a negative 4, negative 4 times negative 3 is a 12, and then 12 times negative 5 is a negative 60. So I'm going to plot that down here on the y-axis. Remember that we established already that our graph has two ends that are pointing upwards, right? So I'm going to put two arrows pointing upwards. Now, on your Delta Math, you guys are going to have to trace it with your fingers. You can use your touch screen, right? But here we go. I have to cut through all of those points. So I'm going to go down, 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 down. I'm going to curve right through it. I'm going to touch that y-intercept, and then I need to come back up to the x-intercept. I need to cut through. You decide how high you want to go. You can stop here, or you can stop earlier, whatever you want. I need to cut through. I'm going to go super low on this one. It doesn't matter for this particular assignment because what they're doing primarily, I should have cut a little bit sooner. Oh no, I forgot it erases the whole thing. Let me lift up my pen here. So what I was saying, you can go as low as you want, as high as you want. What they are looking here in this particular assignment is, are you going through the multiplicities correctly? Are you doing the arrows at the ends correctly? That's the main focal point, okay? So yeah, this is the sketch of our polynomial, and we're done, okay? Hopefully that seems pretty clear to you. You are given this other one as your own. Please pay attention to the fact that these have a multiplicity of 2 and 4, which means at those numbers you are going to bounce. So make sure you bounce like a parabola off that x-axis, whether it's an upward facing parabola or upward or downward facing, you're going to bounce. This is a multiplicity of 1, so you will go right through it. So careful with that problem when you work it out. Thanks for watching.